Okay, so today we're going to be doing the law of sines and cosine. Our objective is students will be able to solve oblique triangles by using the law of sine or cosine. So what are oblique triangles? Oblique triangles are triangles that are not right triangles. And that would help you out. So if they're not right triangles, you're going to be applying either the law of sine or law of cosine. To apply the law of sine, there are three scenarios. Either first scenario, you know the angle side. Second scenario, you know angle side angle. And in the third scenario, you can have side angle. So what is the law of sine's formula? It's sine of capital A over little a, sine of capital B over little b, sine of capital C over little c, where the capital letters are angles and the lowercase letters are sides. And you will only be using two at a time. So either sine of A and sine of B together, or sine of B and sine of C. But you're never going to use all three. So if we jump over to example 1, two ships are 250 feet apart and are traveling to the same port. Find the distance from the port of each ship. I'm going to find the distance of ship A, and then you'll find the distance of ship B. So first thing first, what do we know about triangles? All triangles are equal to 180 degrees. So if I have 39, I have 41, I need it to equal 180. I would just subtract. So 180 minus 41 minus 39. And that should give me my angle that I am missing. So 180 minus 41 minus 39 gives me this angle, and here is 100 degrees. Step 2, we are going to label the triangle because it didn't give me letters. So we are going to label. This is already ship A, so let's call this A. And I know it's kind of hard to see. This is already ship B, so let's call this B. And then we're going to call the port C. And then that can tell us how to label the little ones. That's capital A. This is lowercase a because across. Capital C, little c, capital B, little b. So I'm trying to find little b. That means I have to also include capital B. So I know that these two I need. Now you want to use something that you already have. Like if I use A, they gave me the angle, but do you have lowercase a? No. So that wouldn't be a good thing to use. So then the other ones we're going to use is little c and capital C, because we have those. So then step 3 is the formula. So then step 2, not step 2, sorry. All right, so then we just plug in. We are plugging in what we know. We know capital C is 100. Lowercase c is 250. Capital B is 41. Lowercase b is x. That is my unknown. So let's go ahead and change them to decimals, or you can just cross multiply. It's gonna give you the same thing. You would cross multiply. I like to do everything together, where I just plug everything into the calculator. So then I get this. I divide by sine of 100. If you change the signs into decimals, it's still going to give you the same thing. Now, all of this I can plug into my calculator. So 250 times sine of 41. Make sure that your mode is in degrees because we are talking about degrees. divided by sine of 100. And that gives me 166.5 feet is the distance. So now for your U try, you are looking for this distance here. And that's what I'm going to check for your notes. All right. You can also have or use the law of cosines. You will use the law of cosines when you are either given side, 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 so all three sides, or you would use the law of cosines if you're giving side, angle, side. And the law of cosines, you're only going to use one of the formulas, and they're pretty long, but you are not expected to remember them. Just know when to apply them. So if I have a squared is equal to b squared plus c squared minus 2 times b times c times cosine of capital A. If it begins with little a, it ends with big A. And then we alternate b, and then we're going to do c. So we have a squared plus c squared minus 2 times a times c times cosine of capital B. Starts with a, ends with b, ends with capital B. And then we alternate as a squared plus b squared minus 2 times a times b cosine of capital C. And you're only going to use one. All right, moving on to example 2. The question gives you all the information, 20 feet, 24 feet, and we are trying to find the angle to the nearest degree. So this angle in here. We're going to label our triangle. We have capital A. Across from capital A at 6 feet is little a. Across from capital B, we have little b. Across from capital C, we have little c. I'm trying to find A. So that's the one I know that for sure I need to have. So then for cosine, it's easy. Since I need A, that means I am going to start with the formula that has A in the beginning. And then we just plug it. So formula, you choose one, we plug in. So we know that little a is 6 feet, little b is 24 feet, plus 20 feet, minus 2 times 24 times 20. We don't know cosine of a. That's 36. These can be combined. So then 24 square plus 20 square gives me 976. Now these will be combined, but do not combine it with the 976. It's going to give you, if you do that, you're wrong. 2 times 24 times 20. That gives me 960. You can't combine the 976 and the 960 because the 960 is attached to your cosine. So then I subtract 976. And then I get 36 minus 976, negative 940 is equal to negative 960 cosine of A. We're trying to get cosine, well in the end we're trying to get A, but let's try to get cosine right now alone. So I divide by negative 960. Negative negative gives you positive. 940 divided by 960. It's about 0.97916. That's enough numbers. Cosine of A. Now to get rid of the cosine, we do the inverse. So then the inverse of 0.97916 is going to give me 11.7 degrees. Make sure that your mode is in degrees. So you will try this one for the U try, and I will check your work for that. Moving on to the area of oblique triangles. There are many formulas you can use. The one that is preferred, so something that is called Heron's formula, is S is equal to A plus B plus C over 2. So then you can find the area using the square root of S minus A, times S minus B, times S minus C. Or if you have a side angle side, so if you have only 3 sides, you use this formula. If you have a side angle side, you will use this formula, B times C times sine of angle A over 2. Or if they gave you a different angle, if they gave you angle C, you need A times B angle C over 2. Or if they gave you angle B, you'll just have A times C sine of B over 2. So depending on what angle they gave you. So let's go to example 3. We're finding the area of the triangle. I have side, side, side. That means I have to use the first formula. So that means that we will be using the first formula because we have 3 sides. So we will be using Heron's formula. We start with to find S. So then we add all the sides, 51 plus 38 plus 45. This is an S. I apologize that it looks like a 5. I don't know how to make them different. All over 2, 134, all over 2. So my side is 67. Then I just plug it to the area formula. Square root of 67, and you're going to use each side. 67 minus 38, doesn't matter the order. 67 minus 51. Like I said, the order doesn't matter. 67 minus 45. You can plug that all into the calculator, and the square root, you multiply with your parentheses, you should get 827 inches square for your area. Just a hint, when you're doing the U-try, this one's going to be the second one. You're given angle A, so then the formula you should use is the one that has angle A over 2. So the one I gave you is easier. I will be checking those U-tries when I come back on Friday. I apologize if my cats were making noise. They do not know how to contain themselves. All right, see you Friday. Do your classwork, do your work.